All things in nature share balance, and as human beings, we need a deep understanding of this balance. Let's think about something that helps protect this balance: the ozone layer.
Surrounding our planet, the ozone layer acts as a natural filter for the sun's ultraviolet radiation. In the Earth's stratosphere, oxygen molecules absorb energy from the sun and split to form single atoms. When these atoms combine with the remaining oxygen atoms, they form ozone molecules. From marine life to forests, Earth's ecosystems rely on the ozone layer to protect them from the sun's harmful ultraviolet light. For humans, long-term exposure to direct UV rays can cause skin cancer, sunburns, and premature aging, cataracts, and in extreme cases, if left untreated, blindness can also be caused. Over the years, parts of the ozone layer, particularly around the Earth's poles, has been depleted and is due to what we know as ozone-depleting substances. Ozone-depleting substances, or ODS, are manufactured chemicals which contain chlorine or bromine. One such example would be chlorofluorocarbon, commonly known as CFCs, a name given to compounds which contain carbon, hydrogen, chlorine, and fluorine. CFCs cause little or no threat to the environment or human health in the lower atmosphere, hence their wide usage in the manufacture of cooling products such as refrigerators, freezers, and air conditioners. But when these released as gases into the stratosphere, they began to eat away at the ozone molecules. As this negative effect of CFCs and other ODS on Earth's protective ozone layer became a major concern, research began on alternative substances. On September 16, 1987, the Montreal Protocol was signed by 24 different countries, agreeing to phase out ODSs by the year 2050. As work began on finding alternatives to CFCs, research led to the introduction of hydrofluorocarbons, or HCFCs. This research at the time showed HCFCs had a much lower impact on the ozone layer. Though the ozone-depleting potential of HCFCs may be minimal, researchers did not predict the extended consumption of HCFC products in the years to come. It is estimated that if not controlled, HCFCs could become responsible for about 10 gigatons or 10 billion metric tons of CO2 emissions by the year 2040. Soon the search began for alternatives to HCFCs. Carbon is considered to be the very basis of everything around us, and though there are many possible compounds of carbon and other gases, one of the purest forms of carbon energy is a result of its merging with hydrogen. Thus we arrive at hydrocarbons. Hydrocarbons make for a natural and non-toxic alternative for refrigerants, with no ozone-depleting properties and the lowest global warming potential, and potentially requiring less energy when compared to previous refrigeration gases.
All it takes is an initiative. And in 1987, through the Montreal Protocol, we began that initiative. We succeeded in eliminating CFCs, and now we are well on our way to removing HCFCs. Though it may take a little work, efforts have been made and has been proven successful. As people, we take so much from the world around us, and now our world is changing. To survive, we must adapt and change with it. As resources stretch to support the vast expansion of human life, we do our part to ensure a brighter, healthier world for the generations to come. Yesterday is gone. What tomorrow brings will be determined by today.